In order to make the right choices about your privacy and security, you have to have an understanding about encryption. But you don't need to know the hardcore mathematics. I'll save you that for another course. I'll give you a crash course now on what is important to know so you can make the right choices about what crypto systems to use and understand how encryption can be used to help your security and protect your privacy. It's not an understatement to say that encryption is absolutely the best tool that we have in our arsenal to protect us from hackers and trackers. So, what exactly is encryption? Encryption is a method of transforming readable data, called plain text, into a form that is unreadable, which is called ciphertext. This enables the storage or transmission of data in a form that is unreadable and which remains confidential and private. Decryption is a method to transform ciphertext back into readable plain text. And if I do a quick search on Google here, and there you can see the HTTPS, which means all the content of the web pages are unreadable to anyone who can see the data past them on the network. So that means like your internet service provider or your government maybe, they can only see the destination domain. So you see, this is google.co.uk. Anybody who's sat between me and Google would only know that I was going to Google. They would not know what I was searching for, because this is end-to-end encryption between my browser's application and the server. To simplify things, there are two main components of encryption that you can think about. There is the algorithm and there is the key. So conventionally, the algorithm is publicly known and has been scrutinized by many people in order to determine if the algorithm is strong. And there is the key, which is secret. And you can think of the key like a password in that it must be secret. The algorithm is a bit like a padlock, and the key is like a key for that padlock. The algorithm and key combination determines how the plain text will be jumbled up, which is a process of substitution and transposition of those characters, which just means that they move the characters around and they change a character like A to a Z. And if the algorithm or key are weak, then the encryption will also be weak. So let me show you an example. I want to send a file to a friend Bob, but I don't want anyone to read it. So you need something that can encrypt that file, and I've downloaded something that can do that, and that's WinZip. Many people have WinZip, and I've chosen this deliberately because it's not a specific tool just for encryption, but it enables encryption. So here we have our file for Bob, and if I right click on there, WinZip, add to zip file, using just an evaluation version to demo, and we can see we have an option here, encrypt files. If you're not familiar, WinZip is a compression tool, so it will make the file smaller as I send it, and it packages it up into a .zip file. And at the same time, I can choose to encrypt that file. So if I click on the encrypt file and I look at my options here, I have the option of 256-bit AES, 128-bit AES, and legacy zip 2.0. An AES here is a symmetric algorithm, which means it uses one key. So if I click on OK and add, going to give me some warning here, but then it's going to ask me for the password, and that's going to generate my key. So AES symmetric encryption algorithm uses just one key. The password is converted to the key using something called a key derivation function. So that gives us our algorithm of AES and our key, which is something that is created from our password. Now you can see 128-bit and you can see 256-bit. 256 is the bit length, or you can consider it the strength of the algorithm. The higher the number in these algorithms, generally the stronger the algorithm, but the slower the algorithm to encrypt and decrypt. Think about it, if you had a door and it had many, many locks on it, it would take you a long time to open and close the door, but it arguably could be more secure because it's got more locks on it. So again, this is the same. The higher the bit rate, the more secure it is, but the longer to encrypt and decrypt. The 256 is also the key space, which is the number of total possible different keys that you can have with this encryption algorithm. Now, if you look at this 4-rotor padlock in front of you, and it has 0 to 9 on each rotor, think about how many possible combinations does this have? Well, the answer is 10 times 10 times 10 times 10, which is 10,000. To go through those manually would obviously take a long time, which is why people cut locks and they don't try to crack them in this way. AES with 256 bits has 1.1579 times 10 to the power of 77 possible keys, which is a number so large there is no word to describe it. It's a lot. This means it is very difficult to guess, even with very powerful computers doing the guessing, what the key is, as long as you have used a long and random password to generate the key. And people and governments are trying to crack these algorithms all the time. We know which are the good ones and we know which are the bad ones. We know which ones are susceptible to being cracked and we know which ones are not currently susceptible. When someone tries to guess what the key is by going through every possible combination, we call this technique brute forcing, or brute forcing the key, a brute force attack. You can also do a different type of attack, which is called a dictionary attack, where you try all the words in the dictionary against the key. This is much faster, but if the key isn't in the dictionary, the cracking is obviously going to fail. And the last method that is used is a hybrid of the two methods, where you take the psychology of human behavior and combine it with a dictionary and brute force attack. So an example might be, well, we know that, for example, the word monkey is often used in passwords. It's actually in the top 10 of words used in passwords. So we also know that numbers are often added to the end of passwords. So with that in mind, we can use the word monkey from the dictionary and can use every sort of number combination at the end of monkey to see if we can crack the key. And we're going to talk more on passwords, how to set passwords, password cracking later on. So back to WinZip, an AES here is a symmetric algorithm, which means it uses one key. So if I click on OK and add, going to give me some warning here, but then it's going to ask me for the password, and that's going to generate my key. So AES symmetric encryption algorithm uses just one key. Other examples include DES, which is the data encryption standard, Triple DES, Blowfish, RC4, RC5, RC6, and AES itself stands for Advanced Encryption Standard. Now, symmetric algorithms are used in most encryption systems you'll be using every day. HTTPS, full disk encryption, file encryption, Tor, VPNs, pretty much everything. And AES is the common standard for symmetric encryption. For maximum protection, use where possible AES 256 and avoid RC4 and DES if you have the choice. AES is fast and currently unbreakable. So if we enter a strong random password here, and this is telling us we haven't entered one, but if we did enter one, then we could send this file to Bob. And we can use any method we chose, so email for example. And even governments, militaries, people with lots and lots of resources would find it currently, with current computing power, impossible to crack that AES encryption unless that password was weak. And we'll cover in later sections what is a strong password, what is a weak password, depending on the situation.